find out that my uncle's running a marathon now, so they're all going together.
You're still not in. Only half your face is in. The camera's over here.
Like, I'm gonna go like this.
Got your arms.
Okay.
Your movie star.
They're like going for like 4 days or something. Like, oh dang, that's all it took.
I know. See, I'm in a movie, guys.
Like, yeah, like great.
You're in a movie that maybe viewed by one person
Yes.
twice. If your arms become bigger.
Okay, this is YouTube video of this guy who dances to 240 beats per minute. It's the fastest thing I've ever seen. I was like, what the heck?
Did I assign homework yesterday?
Yeah.
Yes.
82, section 82.
Yes, you did.
I think we have homework from, yeah, 81.
So many questions.
Any questions? Yes?
Yes.
Okay. I'm gonna calculate this. I know, it's ridiculous, but it works. Okay, questions? Where would you like to start, I should say?
Number 6.
From?
81.
81, number 6. Solve the following triangle.
I thought I understood these problems, but I guess I didn't.
40. 8, 6, A, B, C. So I'm going to start by writing out law of sines to see if that will work. I don't think it will in this case. Sine 40 over A equals sine B over 8 equals sine C over 6. Variable in each one, nothing we can do. Okay, so let's go instead to law of cosines. Now the question is going to be which sides are we going to want to use? Well, you know that law of cosines involves the cosine of an angle at the end of it. And if you use this angle then, that's going to help you along the way. So one form of law of cosines is a squared equals b squared plus c squared minus 2bc cosine A. That's going to be a good one because the angle then gets put in here, and then we're going to be able to compute everything out. So a squared equals b is 8, c is 6, bc is 48. We just have to plug and chug, basically. I inadvertently pushed a button that caused the calculator to give an error. And as a result, there it goes. Okay, so a squared equals 64 plus 36 minus 96 times cosine 40, which is 0.766. There's more to it, but that'll work for now. We just have to add that up, basically. So 96 times 0.766 is 75.54, or rather 73.54. So 64 plus 36 minus 73.54, a squared is 26.46.
Yep, okay, I know I do wrong.
You didn't take the square root?
No, for some reason I thought that I should take 96 minus 100, and then, yeah. Instead of multiplying the 96 and the 0.766, I decided I took 96 minus 64 and 36.
Oh, yeah. Order of operations.
Yeah, okay, well,
Yeah.
that would explain my...
That's okay. I mean, hey, that happens. It happens. So now we know what A is.
So I'm not crazy.
I don't think so. No. And then we can use law of sines from here. So looking at this, if we follow the rule that we used last time, rather than going after the side of 8, which could possibly be obtuse and could possibly make life more challenging, let's go after the side of 6, because we know that's acute. I think that's going to be the most user-friendly way to go about it. So we'll say sine 40 over 5.14 equals sine C over 6. Avoiding the biggest side avoids the obtuse angle, avoids that moving into the second quadrant of your sine. I think that's going to make life easier. So we cross multiply here, we get 6 times the sine of 40 equals 5.14 times the sine of C. And the sine of 40 is 0.643. So we take that times 6, and we get 3.86 equals 5.14 times the sine of C. So we divide both sides by 5.14 to get the sine of C. 3.86 divided by 5.14 gives us 0.751, and then we take the inverse side of that to get what C is. C is 48.7 degrees. And as soon as we know that, we know the other one. 48.7 plus 40, take that away from 180, and we get 91.3 degrees. So it actually would have ended up being an obtuse angle, which, oh, I did that wrong, didn't I? I had to have done that wrong.
I got 90 something.
Yeah, 91.3. 91.3. Yeah.
I got 4.
I think that's right.
Yeah.
And the thing that I like about us choosing that smallest side possible then is we avoided, when solving for B, we would have had a 91.3 possibility and what, an 87.7 possibility, and we would not have had to worry about that, and we don't anymore. Other questions? Skylar? Number 8 from that same section? Okay, 2 cables are attached to a vertical tower from a point on the graph as shown. The angle between the cables is 20 degrees, the longer cable is 120 feet, it's attached to the top of the tower, the shorter cable is attached to 60 feet below the top tower, find the length of the shorter cable. Yeah, let me just draw the picture, because the picture really has it all there. So, here's the shorter cable, that's the one that we want to know. Here's the longer cable, that's the one that we know is 120. And here's the 60-foot gap up there, and we know that angle is 20 degrees. So basically we have a triangle that we might be able to use law of sines on, we might be able to use law of cosines on. For the sake of labeling, I'm going to put labels on those guys, and I'll go A and B just to have some label. Now, from the picture, it appears that B is obtuse. So if we went after B in this case, I think we'd be okay because we'd have obtuse. But let's try law of sines, because if law of sines works, we're going to use it. Sine 20 over 60 equals sine B over 120 equals sine A over x. This is a law of sines problem. You can get away with not using law of cosines. Look at the first 2 expressions. If you use those first 2 expressions, you only have one letter. When you cross multiply, you get 120 times the sine of 20 equals 60 times the sine of B. The sine of 20 is 0.342. And when you multiply that by 120, you get 41.04. Divide by 60, and you get the sine of B, 2B, 0.684. Take the inverse sine to get B by itself, and you get B as equals 43.16 degrees. But you say, well, wait a second, 43.16, that can't be right. Look at the angle here. And here's where you can remember, anytime you're doing a sine, it is possible that your angle lies in the first quadrant as a 43.16 degree angle. It is also possible that you're in the second quadrant. You can have obtuse angles in your triangles. You just have to figure out what that angle is. Take 180 minus 43.16, and you will get 136.84. That's the one we need. The 43 degree angle is not going to work for B, but the 136.84 degree angle is. Once you've got the 136.84, add 20 to it, take that away from 180, and you'll get that top angle of 23.16 degrees. And now, you have enough information to use the first and the third statement of your law of sines to find what x is, the missing side. So when you cross multiply the first with the third, you'll have x times the sine of 20 degrees equals 60 times the sine of 23.16 degrees. Sine of 20.342, sine of 23.16, 0.393. So we have 0.342x equals 23.6 divided by 0.342, and we get x equals 69. So the x here is 69. And that makes sense because the smallest angle, 20 degrees, is opposite the side of 60. The slightly larger angle would be opposite the slightly larger side. And the significantly larger angle would be opposite the significantly larger side. It all works out. I suppose answering the question that was asked of you, really the only thing that you need is the x, because everything else was just on your way to getting that answer. Yeah, it didn't say solve the triangle, it said find the length of the sugar table. So, you ultimately, though, going through it, you had to find the other information, because you couldn't have used the first and third expression initially, because the third expression had two variables. So you had to use the first and the second, and then in order to get rid of the two variables, you would have had to use the 180 rule to find what A was in order to then find what x was. So you ultimately had to solve the triangle, but I suppose that wasn't what was asked. Other questions?
28 on the same reason.
Okay, so this is the log problem that was, we brought up a little bit about this yesterday. Log 1/2 of 3x minus 2 minus log 1/2 of x plus 2 equals minus log 1/2 of 4. Now, on the left side, I think it's clear what to do. Subtracting logs comes from dividing numbers, subtracting exponents. So that's what we have on the left. Now, the right was the one that was a little bit tricky, because if you have log on left and log on right, you know that what's in the log on the left is equal to the log on the right, but you don't just have log on the right, you have a negative in front of it. So what I asked you to think about was, think of that as a -1 times the log. And then think you can raise the -1 up as the power of 4. And then you can come over here and say, okay, this is log 1/2 of 1/4. Because 4 to the -1 is 1 over 4 to the 1, which is 1 over 4. And now we can go 3x minus 2 over x plus 2 equals 1 over 4. And cross multiply. So we'll get x plus 2 equals 12x minus 8. We will get 11x equals 10. X equals 10 11ths, which is almost 1. We have to double check that this answer is going to work before we solidify it as our answer. 3x's would be 30 over 11, and 30 over 11 minus 2 would still be positive. 3x minus 2, we need to make sure that what's inside all the logs is positive. It would be in this case. And taking a positive number and adding 2 to it is obviously positive. So that number will work. Other questions? Mm-hmm.
That's on 82 and 9. Got number 10, like all the sides were given, but I got confused on.
Okay. Let's take a look. So, we've got a triangle, angle of 45 degrees, angle of B, angle of C, and sides of A, 9 and 10. So the first step is to check law of sines. And we'll get sine 45 degrees over A equals sine B over 10 equals sine C over 9. Law of sines is not going to do it for us. So what we'll do is use the law of cosines form that includes that angle of 45 degrees. So we'll use the one with cosine A, meaning we'll start with A squared. A squared equals B squared plus C squared minus 2BC cosine A. So thus A squared is 10 squared plus 9 squared minus 2 times 90 times cosine 45 degrees. So the cosine of 45 is 0.707. And then to work this out, we'll have A squared equals 100 plus 81 minus 180 times 0.707. That's 127.26. So 181 minus 127.26 gives us A squared equal to 53.74. Take the square root of both sides. We have A to be 7.33. Now, as soon as we have that, we can start going after the other sides. And rather than going after the sine of b, which could be obtuse, let's go after the sine of c, because the middle length side has to be opposite an acute angle. At most, you can only have one obtuse angle. So I'm going to use the first expression and the third expression. When we cross multiply, we'll get 7.33 times the sine of c equals 9 times the sine of 45. Sine of 45 is also 0.707. So take 0.707 times 9, we'll get 6.363. Divide by 7.33. And we'll get sine of c equals 0.868. Inverse sine, c is 60.2 degrees. And we know that it has to be 60.2 and not the obtuse angle because we're dealing with the middle angle, which cannot be obtuse. And then at that point, if you know the one is 60.2 and you know the other angle is 45, you can subtract from 180 and get 74.8.
Actually, a question on that one. For C, I got 61.09, and for B, I got 73.91. Is that close enough? I think it was just the way I rounded, like when I did. Or does it need to be like?
I'm forgiving, so in that case, it's close enough.
Okay.
In the case of a test or a quiz, I'm going to be looking at your work as well as the final answer. So as long as the steps are good, if the answer's off by a degree or two, that's okay. Yes.
Number 7. Huh?
Section 82, number 7.
Yes. I got 30, but the answer got, I think I got 1.91. So I'm pretty sure.
So we have 6 to the 3x plus 2 power equals 4 to the 2x minus 1 power. Anytime you have variables in the exponents, you log both sides. So when we take the log of this side and the log of that side, the power is going to drop in front, and then we'll just have log 6, and the power is going to drop in front, and we'll just have log 4. The log 6 and the log 4 can be done in the calculator. So log 6 is 0.778, and log 4 is 0.602. So we'll take 0.778 times 3, and we'll get 2.334x, and then we'll take 0.778 times 2, and the number is 1.556. On the other side, we'll take 0.602 times 2, that's 1.204, and 0.602 times 1, 0.602. Whoops. X on 1.204. X is to one side, numbers to the other, so we'll subtract 1.204 x's from both sides, and subtract 1.556 from both sides. So, on the left side we have 2.334x minus 1.204x, which is 1.13x, and on the right side we have 0.602 in the negatives. And we're subtracting 1.556. That's negative 2.158. To get x by itself, we have to divide the 1.13 away. And when we do, we get negative 1.91.
You can use the LN for the problems, right?
Sure.
Okay.
Did you get the same answer or something close?
Yes.
Yep, that's validation.
Okay.
Yep. You could, if you wanted to, you could do log base anything, if you wanted to. It's just that the calculator only comes equipped with log base 10 and log base 8, so that's why we tend to use one or the other. But there actually are formulas that you could use to evaluate even on a calculator logs with bases other than to year 10, but that would be a colossal waste of time. Yeah, good. That makes me happy.
Thank you.
Yeah, we'll keep it simple anyway. Yes, Jordan?
23.
Section 82?
Yeah, sorry.
Find the coordinates of the center of the circle whose equations, or find the radius and the coordinates of the center of the circle. So 23, we want to find the radius and the coordinate of the center of the circle. The equation is 2x squared plus 2y squared minus 12y plus 4x plus 1 equals 0. So as a first order of business, let's remind ourselves what a circle equation looks like. It's going to be nice, rather than having 2x squared and 2y squared, to have x squared and y squared. So one thing we can do first off is just divide the equation by 2. The next thing we might do is say, okay, we want to complete the square with x squared plus 2x. And we want to complete the square with y squared minus 6y. We also want the number on the other side. So we can put that 1/2 on the other side. All I did between step 2 and 3 there is just rearrange in such a way that it's going to be easier to complete the square. Half the middle one and square it, plus 1. Add 1 to the left, add 1 to the right. Half the middle one, negative 3, square it, plus 9. Add 9 to the left, add 9 to the right. So, we have x plus 1 squared and y minus 3 squared equal to, I'll take a shortcut here and just say 9.5. Because negative 1/2 plus 10 is 9.5. So, where's the center of the circle? Well, you can see there's shifts here from the normal circle. So the x has been shifted left 1, and the y has been shifted up 3. So, based on that, that's the coordinate of the center. The 9.5 is the radius squared. So, if 9.5 equals the radius squared, then the radius is the square root of 9.5, which is 3.08.
In the homework they asked for the equations of the asymptotes when we were doing hyperbolae. I was just wondering if you reviewed that really quick.
So, I assume the hyperbolas you were asked to graph went through the origin, or rather the boxes that you drew were centered around the origin. Is that right? So, when you draw your boxes, you're going some number of units to the right and to the left, and some number of units up and down. Now, the asymptotes going through the origin have a 0 for their y-intercept. So the lines are essentially y equals mx, right? But now what is the slope? The slope can actually be determined by going over a units up b. So the rise is b, the run is a. You'd have that guy. And then this one would be negatively sloped line, rise is b, run is a. Like that. So, B's and A's weren't your problem, but that works every time. Okay, so before leaving, please drop off your homework from 81 and 82, and then next time, tomorrow, Thursday, we'll venture into some new stuff.
Do you know where I got
Probably next Friday.